because you can figure it out without knowing this formula. You can reason it through just knowing a little bit about circles. So for instance, if I look at this example, it says, given a central angle of 60 degrees and a radius of 8 centimeters, find the length of the intercepted arc. Well, what we're talking about here, if it has a central angle of 60 degrees, Caleb, you taking notes? Central angle of 60, oh, your iPad's dead. Oh, I see. I'm sorry about that. And a radius of 8 centimeters. It's asking me to find the length of the intercepting arc. So I'm going to show you how you could do this without knowing the formula. But the formula is so much quicker and easier. And it's actually a very simple formula, right? So the arc length is basically talking about the edge of the circle. Well, what do we know about the arc length of a full circle? What's that? What's another name for that? The circumference, yeah. And we know circumference is 2 pi r. Okay. So if the radius is 8, I know the arc length of the entire circle. So I can do, 2 pi r. So the circumference of the entire circle is going to be 16 pi. So I'm going to do the entire circle, 16 pi, to 360 degrees, because that's how many degrees are in the entire circle. And I'm going to set up a proportion. This will be equal to this arc length, we're going to call that x over 60 degrees. So I'm taking the whole circle. I can take the circumference of the whole circle and the degrees of the whole circle, and then the arc length of the sector and the degrees of the sector. And then I can solve that proportion. So we've got 16 times 60. So that is 960 pi equals 360x. So divided by 360. I get 8 over 3 pi. Okay. So that is the length of that arc, that intercepted arc. Okay. So you can do this. You can reason through it without knowing any formulas. But now let's do it using the formula. So first off, in this formula, S represents the arc length, right? So we'll call this S instead of X. Okay. S represents the arc length. And in this formula, theta, the angle, has to be in radians. So that's the only extra little step you have to do. We need to convert that 60 degrees to radians. And how do we do that? How do we convert 60 degrees to radians? Morgan, how do we convert 60 degrees to radians?
Multiply by pi over 180.
Pi over 180, good. So that gives us pi over 3. Okay, so this is pi over 3, this angle. Okay, so now we're going to use the formula. S equals r theta. So S equals r is 8. Theta is pi over 3. So we get 8 over 3 pi. And that is the length. I should say centimeters. That's the length of my arc. Okay. Much quicker with the formula, but it is doable without the formula. That's why I almost chose to skip it, but changed my mind. Okay. Okay. So see if you can do example number 2. If a 100-degree arc of a circle has a length of 9 inches, all right? Oops. Okay, 100 degrees. The arc has a length of 9 inches. What is the radius? Okay, see if you can do that. Okay. So we have S equals R theta. So what's the first thing we have to do? Yes. Change the 100 to radians, right? 100 degrees to radians. 100 degrees to radians, so we're going to multiply by pi over 180. So that's going to be 10 over 18 pi or 5 over 9 pi. So first we have to change that to radians, okay? And I'm trying to solve for r. So if S equals R theta, then R equals S over theta. Bless you. So R equals 9 over 5 over 9 pi. What do we do when we have a fraction in the denominator? Flip and multiply. So 9 times 9 over 5 pi, which equals 81 over 5 pi. Okay. Now, if you notice, it says to round it to the nearest inch. That means we want the decimal equivalent of this. If it said the exact value, we'd leave it like that. Since it's telling me to round it to the nearest inch, I need to figure out the decimal equivalent. So 81 divided by 5 times pi. I need you to all get your calculators out and everybody do this. Oops, wait a minute. That pi is in the denominator, isn't it?
Oh, it's 9 over 5.
Yeah, the pi should be in the denominator there. Sorry about that. Yeah. Right. Okay. So let's see. I'm going to do 81 divided by 5 times pi. Okay. How many people got 50 over 50.89? Anybody get that? How many people got 5.156? Anybody get that? This is the correct answer. Okay, so this is what you have, right? And this is why I wanted you to get your calculator out. You've got 81 over 5 pi. Now, if you put it in your calculator like this, 81 divided by 5 pi, it's going to do that. And if it does that, that's 81 over 5 times pi. But the pi's in the denominator. So we have to put this 5 pi in parentheses. Otherwise, it does 81 divided by 5, takes that answer and multiplies it times pi. and that gives us the 50.89. If we do 81 divided by 5 pi in parentheses, I get the 5.156, okay, which is rounded to the nearest inch of 5 inches, approximately 5 inches. Okay, you have to be very careful with your parentheses, right? Very careful with your parentheses. Okay, number 3, find the angle in radians, convert to the nearest degree. So again, S equals R theta. So theta equals S over R. So we get, let's see, S is 8, R is 5. Okay, so we have 8 over 5. Is that degrees or angle or radians? Is that degrees or radians? Look at the formula. Theta is in radians. So if I solve for theta, what's it in? Radians. So we want to round it to the nearest degree. Okay, so what do we do? Ava, what would I do to change this to degrees? 180 over pi, right? 180 over pi. All right, so again, use your parentheses. So I'm going to put this in my calculator, 8 divided by 5 times 180 divided by pi. Make sure you use your parentheses. And I get approximately 91.67. It says rounded to the nearest degree, so we're looking at approximately 92 degrees. Okay? All right, any questions on arc length? Pretty straightforward. The trick is you have to make sure you're working in radians. Okay? Okay, the other one I want to look at with you is we're going to skip all of this angular velocity and linear velocity, and we're going to jump down to area of a sector. Okay. Again, this is something that you could do just using proportions, but this is a really convenient formula. The area of a sector is 1/2 pi r squared theta. We know the area of a circle is pi r squared. But if I have just a sector, right? So if I'm looking for the area of that sector right there, it's 1/2 pi r squared theta. So again, you could set up a proportion, or you could use this formula, right? They like to put this on the SATs. Find the area of the sector of a circle with a radius of 2 formed by the angle 50 degrees. Round your answer to 2 decimal places. Okay, here's my circle. Okay, and here's my sector. This is 50 degrees, and it has a radius of 2. Notice I don't need to know the arc length to find the radius of that sector. So I'm looking for, to find the area of that sector. I'm looking for this area right here. So what do I have to do? Alex, what do I have to do? I got my formula, area equals 1/2 r squared theta. So do we know r? Okay, what's r? 2. Okay, so r squared is 4. Do we know theta? Okay, why not? The angle is 50 degrees. That's theta. But what do I have to do to that angle, Gavin? Change it to radians, right. So we've got to change that 50 degrees to radians. So we multiply by pi over 180. Okay, I'm going to leave it in terms of pi. So on my calculator, I'm just going to do 50 divided by 180. Actually, let me make sure I show you how to do this. So on my calculator, I'm going to just do the 50 divided by 180. I get a decimal, but then I'm going to press math and convert that to fraction. So that's 5 over 18. So I'm going to use 5 over 18 pi for my radians. Okay. 5 pi over 18. I'll write it like that. Okay. So my area is 2 times 5 pi over 18, which is 5 pi over 9. But again, it says to round it to 2 decimal places. That tells me that I'm not leaving it as 5 pi over 9. That tells me I need to do the decimal equivalent of that. So we're going to, in parentheses, do 5 times pi divided by 9. And we get 1.745, 2 decimal places. So this is approximately 1.75. Okay, let's figure out our unit. Okay, let's figure out our unit. So look at the formula. The radius was feet. So I have feet squared. And the angle was in radians, so I don't have to put anything there. So this is just feet squared. Okay. Okay. Yes.
For that one, why did you do 1/2 times 4 before you did 4 times 5 pi over 18?
It doesn't actually matter because multiplication is commutative. So I could have just done the 5 pi over 18 times 4 and then times 2, come out the same. Okay. Okay. This is kind of a cool one. Okay, this example. So Memphis, Tennessee is located 35 degrees 9 minutes north latitude, and New Orleans, Louisiana is at 29 degrees 57 minutes north latitude. Assuming that the radius of the Earth is 3,960 miles, the cities lie along the same longitude. Find the distance between the two cities. Okay, so this is what we're looking at. Okay, here's my Earth, all right? Basically, what they're saying is that the cities, oops, I drew it the wrong way. It said latitude, didn't it? The cities are going to lie on the same latitude, okay? So what we're actually looking at, let me see if I can draw. I'm not very good at drawing these. I'm sorry. Give you my apologies ahead of time. What we're looking at is we know the radius of the Earth, okay? The radius of the Earth is going to be 3,960 miles, okay? And then we've got, I don't know why I'm so bad at drawing this. I'm going to not draw it on the actual circle. I'm just going to draw it differently here. I'm trying to do it curvy and it's messing me up. Okay. Here's the radius of the Earth, 3,960, okay? And then here's New Orleans, okay? And then here's Memphis. Okay, this is not the Earth, by the way. That circle is representing basically the latitude. Okay. So what it's saying, right here's the latitude, is that they lie on the same latitude. Now Memphis is 39 degrees 35 degrees 9 minutes. And Louisiana, or New Orleans, is 29 degrees 57 minutes. Okay. I'm trying to find how far apart the two are. So I'm actually looking for this value right here, that arc length. In order to find that arc length, I need this angle. So we kind of have to understand a little bit about the latitude. When it says 35 degrees 9 minutes north latitude, that means north of the equator. So Memphis is 35 degrees 9 minutes north of the equator. I'm going to let this represent the equator right here. And that's why it was so hard to draw. I was trying to do it all curvy and it was not working. So we're just going to draw it like a straight line. Okay, that represents my equator. New Orleans is 29 degrees 57 minutes north of the equator. Okay, so this is the sector that I'm actually looking at. This sector right here, because I want to find how far apart the two are. Here's New Orleans. Here's Memphis. So we're looking at which formula? Is it area equals 1/2 r squared theta, or is it S equals r theta? Which formula am I looking at? S equals r theta, yeah. So we're trying to find S. Do I know r? What's the radius? Yeah, 3,960 miles. Okay, theta, now we've got a little bit of work we have to do. So in order to find theta, right, I need to take the distance that Memphis is from the equator. So I need to take that distance and I need to subtract this. That's going to give me theta here. So basically I need to take the 35 degrees 9 minutes and subtract the 29 degrees 57 minutes. And that's going to give me theta. Okay. But I have an issue here, don't I? What's my issue? Do you know how to subtract that? Jordan, do you know how to subtract that? Why not? Because we got those minutes in there. Right. So let's convert that to just decimal degrees. Okay, so we're going to go ahead and just use our calculator to help us save some time. 35 degrees 9 minutes. Okay, 35, we're going to go into our angle, choose degrees. 9 minutes, we go back into angle, choose minutes. Make sure you're in the degree mode. Okay, and when we press enter, we get 35.15. Okay, so this is 35.15 degrees. And then we're going to convert the other one to degrees, 29 and 57. Okay, 29 degrees, 57 minutes. Okay, 29.95. Say again? You mean the mode?
No, how do you,
So once you do this, if you're in degree mode, all you just do is press enter and it'll put it in degrees. It's going to give you the decimal value in degrees.
how did you get the little degrees?
Oh, go into the angle, second angle. Okay. Okay, so now we've got to subtract them. 35.15 minus 29.95, and that equals 5.2 degrees. All right, we good to go? Are we good to go? Is that my theta? Mika, is that theta? No, so what do I have to do? Say again? Okay. Yep. Yes, convert it to radians. So we're going to multiply by pi over 180. Okay, so let's see here. We're going to take that 5.2 times parentheses pi divided by 180. And we get 0.09057. Whoops. Yeah. 0.09057. I'm going to leave it long like that for now. Okay. So I'm going to go back up here and I'm going to put that in for my theta. 0.09057. The only reason I put that 0 in front is so that I clearly see the decimal point, because sometimes you just have little dots on your paper and you kind of lose track of the decimal. Although 9,057 degrees doesn't really make sense. Okay, we're going to multiply that by 3,960.
Is this supposed to be 0.7557?
757. Okay. 757. Thank you. 757. Okay. Okay, so S is approximately 359.398. Okay, so we are rounding it to it doesn't say what to round it to, right? 359 miles approximately. Okay. Kind of tricky, but it's kind of cool too. Questions? Okay, so I would like you to work on homework 4.3. Let me just make sure that I cleared it on your Google Calendar. Yeah. Yeah. Okay, you should be okay with these, I think. I want you to do just numbers 1 through 8. Okay, homework 4.3, numbers 1 through 8. Okay, questions for me? Okay, this is what our quiz will be on Friday. Okay. I'm just going to stop you for a moment. I know you're all diligently working on